Welcome to All Limans TV. My name remains Jakes Animal, and today we have a challenge on logarithm equation. But before we go into today's challenge, if you are new to this channel, kindly subscribe. And when you subscribe, turn on the bell notification button so that YouTube can notify you whenever we drop videos every day, because we drop new videos every day in this channel. So let's go into today's challenge without much waste of time. The question says log n base 8 equal to arrow all over 2, and log 2n base 2 equals to x, then x minus arrow equal to 4, then n is equal to what? What will be the value of n from these three equations? So let's take down our solution. So you have here solution. We write down our equation. Equation 1, we have log n base 8 equal to arrow all over 2. I want to give this equation 1. I want to label this equation 1. Then second one, we have log 2n base 2 equal to x. And I want to label this equation 2. Then the last one, which is x minus arrow equal to 4. I want to label this equation 3. Okay, the essence of labeling this equation 1, 2, 3, so that whenever I make mention of equation 1 or equation 2, you know the particular one I'm talking about. Now, from these three equations, this is the main equation we're going to work with. X minus arrow equal to 4. Okay, so we have to bring out arrow from equation 1. Already x is already brought out from equation 2. Okay, so we take our equation 1 and bring out arrow. For us to get arrow, we multiply through by 2. Okay, we multiply both sides by 2. So let's put that down in writing. You say from equation 1 multiply both sides by 2. Okay, so let's proceed from here and see what this gives us. Okay, so this, if we multiply both sides by 2, is going to give us here 2 log n base 8 equal to arrow all over 2 times 2 times 2. Okay, if we do this 2 we go with this 2. So we are now left with our 2 log n base 8 equal to arrow. Okay, now that we've gotten our arrow, let's label this equation 4. Let's give this equation 4. Okay, now we now have our arrow played out. We also have our x played out now. So we can now substitute arrow and x into equation 4. So from here, we now put it down in writing. It said, put equation 2 and 4 into equation 3. We want to put equation 2, equation 4 into this equation 3. Okay, so from here we write down our equation 3. So our equation 3 says x minus arrow equal to 4. So wherever we see x, which is this, we put down this. Then from here we now have here log 2n base 2 minus our arrow this 2 log n base 8 or equal to 4. Very easy. Okay, so let's proceed. Yeah, we are having the smallest base to 2. Okay, here we are having 8. So we can bring this base to 2. And so we succumb to the law of logarithm, which is known as the change of base law. what does it say? It says if you have something of this kind, if you have a logarithm of like log k base b, and this base is not convenient to manipulate with the base, with the log itself, what do? Change this. So if you change this, you can change this to k. So this will give you log k base k all over log b base k, where k is the new base number. All right. So if we apply that here, then this will give us something different. But before I continue, there is a video I produced on the major laws of logarithm. It's showing up here now. Okay, you can watch that video later to see this law. This law is among the 9 laws I listed out there. Okay, so let's proceed to change this to base 2. So this will now give us log 2n base 2 minus 2 or equal, okay, or into your log n base 2 all over log 8 base 2 close bracket equal to 4. Very easy. Okay, now from here we look again. This 8 is the same thing as 2 to the power of 3. So if we rewrite that, this will now give us log 2n base 2 minus 2 into log n base 2 all over log 2 to the power of 3 base 2 close bracket equal to 4. Nothing has really changed from here. Okay, we look again. This is a power already. And there's also another law in logarithm, which is called the power law. What does it say? It says that if you have log m to the power of p base k, bring this power back. So this will now give you p log m base k. So if we apply that here, we have to move this 3 backward. And so this expression in turn becomes, so let's proceed from here again. From here, let's proceed. Okay. Okay. So let's proceed. So this is going to give us here log 2n base 2, okay, minus 2 into log n base 2 all over, okay, let's separate this out, leaks, all over, okay, all over your 3 log 2 base 2, close bracket here. All right. Now, we have another leg which says that if you have log a base a is equal to 1, provided a is not equal to 0. So this is log 2 base itself again. And so if we apply that, the whole of this place will become 1, which is 3 times 1 will give us 3. So this expression will now become log 2n base 2 minus 2 into log n base 2 close bracket all over 3 equal to 4. Right here also equal to 4 here, please. Okay. From here, we can bring out this 3 here. So this expression will now in turn give us log 2n base 2 minus 2 all over 3 into log n base 2 close bracket equal to 4. So let's continue. But before we continue again, if you are new to this channel, don't forget to subscribe. Don't forget to subscribe. Subscribe because we drop new videos every day. Okay, so let's continue again. Okay, from here now, look at what we have here now. This automatically will give us log 2n base 2 minus log your n to the power of 2 all over 3 base 2. According to the power law I just explained now, we bring this one back to this power. Okay. All right. We are having a subtraction here now. So we succumb to the division law of logarithm. Division law of logarithm says that if you have log m divided by n all to the power base of a, this is same thing as log m base a minus log n base a. Very easy. So our expression here now is in this form now. We want to take it back to this form. So this will now in turn give us log. They are having the same base, okay? Base 2. So we're going to have here 2n all over n to the power of 2 all over 3. Close bracket. Or equal to 4. Very easy. Let's proceed from here. Let's proceed from here and see what this gives us. Okay. We are having n here, we are having n here, and the power of n here, mind you, is raised to invisible 1. So if n is to the power of invisible 1, then we can carry out the division law of indices. Okay, according to the law of indices, we apply the law of indices here. It says that if you have m to the power of a all over m to the power of b, this is equal to m to the power of a minus b. So long there is a division and the bases are the same, subtract the powers. So n is here, and we have a power, So let's subtract the power. So if we rewrite this will automatically give us log base 2, I have here 2 into n to the power of 1 minus 2 all over 3. Let's put this in bracket. Okay, all equal to 4. Okay, if we simplify this expression we have here, 1 minus 2 all over 3, this will automatically give us 3 minus 2 all over 3 by taking the LCM, and which we in turn will give us 1 all over 3. So the whole of this will now give us log 2n to the power of 1 all over 3 base 2. Okay, let's put all this in bracket, equal to 4. We are having log base 2. So let's introduce log to this other side. It's going to be log base 2. Also remember that log a base a is equal to 1. So if we succumb to this law, this side of the equation is same thing as 4 log 2 base 2. Because log 2 base 2 will give us 1. And 1 times 4 will give us 4. So if we go on with this, we're going to have here log bracket 2n to the power of 1 all over 3 close bracket base 2 equal to, here we have log 2 to the power of 4 base 2. Simple. We are having log base 2, log base 2. So automatically, this will go with this. So we equate the exponents. So if we do that, so if we equate the log, so we're going to have here 2 to the power of 2n to the power of 1 all over 3 equal to 2 to the power of 4. Very easy. From here, let's divide by 2. So if we divide through by 2, divide this by 2, so automatically, here we have to the power of 1, then this and this will leave. Then the right-hand side of our equation is going to give us, we succumb to the division law of indices again. So since the bases are the same, subtract the power. So we have here 2 to the power of 4 minus 1, which is equal to 2 to the power of 3. So our equation will automatically become n to the power of 1 all over 3 equal to 2 to the power of 3. Very easy now. Okay, yeah. We are looking for n, mind you. That is what we are asked to look for. So from here, we take the cube of both sides to eliminate this cube root. Okay, so from here, we now say cube both sides. We say cube both sides. If we do that, so we're going to have this to be n to the power of 1 all over 3, or to the power of 3 equals to 2 to the power of 3, or to the power of 3 again. Okay, this, we go with this. So n will be exposed. And 2 to the power of 3, according to the law of indices again, which says that if you have a to the power of m all to the power of n, this is same thing as a to the power of m n. So if we multiply this power, this will in turn give us 2 to the power of 9. And what is 2 to the power of 9? It means 2 times 2 times 2 times 2 into 9 places. And that will give us 512. And so, therefore, our n is equal to 512. And this is what we are asked to look for. Very easy. Q, E, D. All right, so that is the end of this simple challenge. If you have learned something good from this challenge, drop it in the comment section. Or you have a better way of solving this, also drop it in the comment section. Okay, if you love what is happening here, give our video a thumbs up, because this helps to fast track the channel. Okay, all right, remember, Jakes loves you, and all of us at Online Maths TV love you. Thanks for always be there. Bye for now.